Hello students, welcome to my channel Positron. Today's topic is a problem based on electrostatics. Uh, my last video, some videos were related to the electrostatics in which I have covered Coulomb's law in vector form, electric dipole, field due to dipole, and many videos I have made. Now that topic is finished. Now I think it's better is to solve the problems regarding to the electrostatics. First problem that is more often asked in question papers, that is field due to uniformly charged ring. Electric field due to uniformly charged ring. Right? Let this is a ring. Dear students, this is the ring on which charge is distributed uniformly. Dear students, actual ring is this much. Ring is this much. Okay? Because we have to find out the field at a point existing on the axis of the ring, and that is axis is like this. That is, axis is what? Passing through a center of mass and perpendicular to the plane. So axis would exist at this point. That is why I have to make this shape, because I can make the axis like this, and it is a point P here where we have to find out the field. Now, dear students, what is the problem? That this is a ring. Let it has charge distributed is Q, radius is A, and a point is small x distance away from the center of the ring where we have to find out the field. Dear students, the limitations of Coulomb's law is what? Coulomb's law is applicable for the point charges, right? We consider a point charges, this is a point charge. Means a charge which is very small, that you can consider it as a point, right? Now, dear students, ring is a bigger body. This is a ring on which charge is distributed uniformly. Total charge on the ring is Q. The radius of the ring is small a, and a point P is small x distance away from the center of the ring where we have to find out the field. Dear students, in order to apply what I am doing, we have only one tool, that is Coulomb's law. In order to find out the field at any point, what we have to do, we just have to apply the Coulomb's law. In order to apply the Coulomb's law, what I am doing, we are supposing that it is made of number of small strips, right? And that small strip will behave like why do we consider, why don't you apply that ring? Why don't you find the electric field at point P just considering whole ring? Because ring is a bigger body. You cannot apply the Coulomb's law. In order to apply the Coulomb's law, you have to consider that a relevant shape you have to consider that of which that body is made. This body, like you can suppose, it is made of number of small strips. One such a strip has the length dl, right? And on this strip, let the charge is q, dq. Dear students, in order to find out the field at point P, which is small x distance away from the ring, center of the ring, which has the radius small a, what I have supposed, we have assumed that this ring is made of number of small strips. One such a strip which is having length dl, charge is dq. Let lambda is charge per unit length. Charge per unit length. Dear students, there is a bit confusion in our mind. Sometimes we what we used to say that charge density means charge per unit volume. This is not true. Charge density might be the charge per unit length, charge per unit area, charge per unit volume. That depends on the shape of the body. If you are considering thin and uniform wire, then the charge distribution you have to consider charge per unit length. If it is a disk, then we will consider charge density as a charge per unit area. If it is a sphere, we will consider charge density as a charge per unit volume. Now, dear students, here we have to find what we will do. We will find out the field at point P due to this small strip, and then we will integrate it. And integration, integration means add, summation, right? And differentiation means breaking. Dear students, when I was beginning my journey with you all, I have told you all that there are the three main basic instruments, tools. You have to be the master, not master, at least you have to be familiar if you want to have if you want to acknowledge the good physics. That is what calculus and graphical analysis and vector analysis. These three things you should have a good knowledge of these things. These are the ABCD of physics. Now, dear students, what I'm going to do, I'm going to find out the field at point P due to this small strip. So, field at P due to assumed strip. What will we write it like? D is equal to 1 upon 4 pi epsilon naught. That is, let the charge in this strip is dq over r square. R square is this, that is r square. R you can write 1 upon 4 pi epsilon naught dq over a square plus x square. Now, dear students, dq, lambda is a charge per unit length. This strip, we have assumed that this strip has the length dl. Then what charge will accommodate in length dl? That is dq is equal to, you can write lambda into dl. So, dear student, de is equal to 1 upon 4 pi epsilon naught. dq you can replace by lambda dl upon a square plus x square. Now, dear students, this is the field you have find out due to a small portion, a small element existing on this ring at point P. Now, this field is D. Dear students, now look here, field is a DE like this, right? How will you find out the direction of the field at a point where you are measuring the field? In order to find out the direction of the field at any point, you have to assume, you have to consider, you have to imagine a positive test charge placed at that point. If you place a positive test charge at this point, this charge, this positive charge will repel this charge along the line joining them. Let this angle is theta, then this is theta. D has the component along the axis D cos theta and perpendicular to the axis D sin theta. Now, dear students, if this assumption you have made in the lower half of the ring like this, then D would have been like this, and D cos theta would have been this, and D sin theta would have been this in this case. So, due to upper and lower half, the y component of the DE will cancel to each other. Due to upper and lower component of the ring, the sine component or the y component of the field will cancel to each other. So net field at point P, what will net field? E is equal to dE cos theta. Now, dear students, sometimes people do ask to me, you might be confused that it is a d cos theta due to this one component and d cos theta due to this component, so it becomes 2d cos theta. Why do we write integral d cos theta? Actually, in 2d cos theta is just wrong. Integral d cos theta means you are considering all those components along the x-axis, whether the point is in upper half or in lower half. What I mean to say that integral d cos theta is sufficient. This integral d cos theta represents that you are considering all those components of the field which is along the x-axis, whether the strip is in upper half or in lower half. Now, the what we want we have got, right? That is our problem. We have to find out the field due to whole ring, whether the strip is in upper half or in lower half. Now, E is equal to di strength. I am replacing the value of d, that is 1 upon 4 pi epsilon naught lambda dl upon a square plus x square cos theta. I am very sure you people must be following. Let me check. Can you see the board? Yeah, right. Now di strength, look here, E is equal to lambda upon 4 pi epsilon naught I am taking out. It's a constant. You can take in or out of the integration or differentiation, no matters. dl over a square plus x square. Now look here, cos theta. Cos theta, consider in this angle, that is base upon hypo, that is x upon r. And r is what? That is a square plus x square. Square root means to the power 1 by 2. Now di strength, it becomes lambda upon 4 pi epsilon naught. A square plus x square, a square plus x square, that becomes a square plus x square to the power 3 by 2. X take out. Now it's a dl. dl is what? dl, that is, dl is this. So integral dl is the length of the assumed strip. So integral dl is, that is, this ring is made of such a strips, right? Integral dl means you are adding, you are integrating, you are taking summation of such a strips and that will turn into the ring. Means this integral dl actually represents this whole ring, and integral dl is that is perimeter of whole ring, and that works out to be di strength 2 pi a. A bit on erasing here. Now di strength, what we have got, E is equal to 1 upon 4 pi epsilon naught. Now this is lambda into 2 pi a x over a square plus x square to the power 3 by 2. Now look here, lambda is a charge per unit length. Then charge on 2 pi a, total perimeter is the total charge. So lambda into 2 pi a is actually what? That is a total charge q. So E is equal to 1 upon 4 pi epsilon naught q x over a square plus x square to the power 3 by 2. So in this way, we have got the value of electric field is this. The value of electric field is equal to 1 upon 4 pi epsilon naught q into x over a square plus x square to the power 3 by 2. Dear student, sometime it is asked, look here, I am just expanding this problem. What we have find out, it was a ring, the total charge was distributed q, the radius was a, and a point P was existing at a distance small x away from the center of the ring, where at this point we have find out E is equal to 1 upon 4 pi epsilon naught q into x over a square plus x square to the power 3 by 2. This is point P is existing at the axis of the ring. Now dear student, question might be asked that what would be the maximum value of electric field and where that electric field will be. Where will be the electric field maximum on the axis, and what will be the maximum value of electric field. Now I'm just indicating that I'm going to use calculus. Dear student, the value of E is this. In order to find out the means for which value of x, question is that in easy language you can understand that for which value of x electric field will be maximum and what will be the maximum value of electric field. In order to find that, let's find d over dx, differentiate with respect to x. Now dear student, q 4 pi epsilon naught, these all are the constants, take out d by dx of x over a square plus x square to the power 3 by 2. You know, there is a formula d by dx of L upon m, that is m dl upon dx minus L dm upon dx over m square. This kind of formula is. This what I am applying, dear student, look here, q upon 4 pi epsilon naught. Take this out, a square plus x square to the power 3 by 2. Now d by dx of x, that is 1, right? You know the basic formula used is d by dx of x to the power n is equal to nx to the power n minus 1. So d by dx is of x equal to 1. Minus, take x out, that is d by dx of that much. d by dx of a square plus x square to the power 3 by 2. Dear students, what we have to do, I am telling you directly because I have not made the videos on calculus. The day I'll make the videos on calculus, everything will be clear. But if you want to solve this, now what you have to look, that you are different, d by dx means you are differentiating this function with respect to x. So a is a constant. First, assume this whole thing is a like x. So x to the power n is equal to nx to the power n minus 1. That is n means 3 by 2. X means a square plus x square here, right? To the power n minus 1. 3 by 2 minus 1 means 1 by 2. Now again just differentiate this very term again, and you a is a constant, differentiation constant is 0, and now x square differentiation turn out to be 2x, 2 will be cancelled, you will get 3x a square plus x square to the power 1 by 2. So here is what we have got, 3x a square plus x square to the power 1 by 2, right? Yes, we have taken x out and differentiating this results into this. Now over square of this, that is a square plus x square 3 by 2. If you will square this, now 1 by 2 will cancel by 2, so it is actually cube, and this turns out to be 0. Why? This is a condition for dy upon dx is 0 if the value of y is maximum for x, right? We have to find out what we are going to do, that on this axis for which value of x e will be maximum. We are trying to find out the value of x for which e will be maximum. So for that, for the maxima and minima, we have applied d upon dx equal to 0. Why do we put 0? Actually, ds if the graph is between y and x, just you can understand in a brief at a glance. It is, this is a graph between y and x, then maxima is this and minima is this. dy upon dx is what? dy upon dx is actually the tangent of the slope drawn at the point. If dy upon dx at a point represents the tangent, slope of the tangent, at the maxima, tangent you will draw like this, at the minima, tangent will be like this. So m is equal to tan theta, and that is equal to tan 0, and that is equal to 0. Why? It is y0. Dear student, at maxima and minima, the tangent will be parallel to the x-axis, which is having the slope 0, and slope of the tangent is expressed as tan theta, theta equal to 0, so tan 0 equal to 0. That is why either for maximum and minimum we put the differentiation of the function 0. Why? Because the slope of tangent at maximum and minimum becomes 0. Now dear student, this is 0. What we have got? Bring to this, that turn out to be 0. Bring to this side, that turn out to be 0. Now it is a square plus x square to the power 3 by 2 minus what we have got, 3x square a square plus x square to the power 1 by 2, that turns out to be 0. Now dear student, a square plus x square to the power 3 by 2 equal to 3x square a square plus x square to the power 1 by 2. Bring it to that side, you will get what you will get, a square plus x square, right? This is a square plus x square into a square plus x square to the power 1 by 2 to the power 1 by 2. That portion will be cancelled, you will be left, and here will be left 3x square or 2x square. Bring this, transform this to LHS. This is x square or x square equal to a square by 2. Or dear student, you have got x is equal to plus minus a by root 2. Means either it means this is your ring, right? Either this side of x is equal to plus a by root 2, or at this side x is equal to minus a by root 2. At these 2 points, electric field due to ring will be maximum, and these 2 points are existing on the axis of the ring. Now dear students, what we have to do now, this is, you have find out the value of x, that is equal to a by root 2 plus minus a by root 2. At for this value of x, the value of E will be maximum. Now you can find out the maximum value of E max. That works out to be, how you can find out, E max is equal, E is this. Now replace the value of x is equal to a by root 2. So it is a q upon 4 pi epsilon naught on taking out, right? X is a, that is a by root 2. Now a square plus a by root 2 square, that turns out to be a square by 2 to the power 3 by 2. Now dear students, it turns out to be q upon 4 root 2 pi epsilon, root 2 I have brought here, 4 root 2 pi epsilon naught a over, this is 3a square, this is 3a square by 2, right? 3a square by 2 to the power 3 by 2. Dear student, to the power 3 by 2 is what? In easy language you can understand like this. 1 by 2 is this square root and cube of that. 3a square by root 2 by 2 into 3a square by 2 into 3a square by 2. Means of this is actually this. Now these two are make a pair, take out, and this turn out to be a root 3 by 2. So what we have got, this is q upon 4 root 2 pi epsilon naught. This was a. Now it is 3a square by 2 into a root 3 by root 2. Now dear student, this root 2 will be cancelled. This 2 2s are 4. And now this a will be cancelled. So you have got E, the maximum value of electric field due to ring at a point on the axis of its, that is E is equal to q upon, that is 3 to the 6 root 3, 3 to the 6 root 3 pi epsilon naught. This is the value of maximum electric field, right? Due to ring at a point existing on the axis of the ring. Dear student, sometimes a question is asked like this. Problem is, I'm not solving the problem, just telling you that how you can solve, and easily you can solve. If there is a problem regarding to my videos, do ask to me, do comment. I will try my best to tell you. Dear student, a problem might be like this. This is plus Q charge, this is minus Q charge, this is plus Q charge. And now you have to find out the field due to field at this point, right? Are the force acting on charge minus Q. Why the force is acting on the charge minus Q? Because of these two charges, right? Now you have to find out the force acting on minus Q charge. What we have to find out? The force acting on minus Q charge. Dear student, this plus Q charge will attract this charge like this. This plus Q charge will attract like this. Now dear student, let it is an equilateral triangle, right? Having each side is small a. For our convenience, I have supposed that it is an equilateral triangle. If you imagine an isolateral triangle, even then it will work. Now, for the convenience, I have assumed that it is an equilateral triangle. We have to find out the field at minus Q. You know, the force acting between the two charges due to Coulomb's law, F is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. If on this charge, due to this charge, that is 1 upon 4 pi epsilon naught Q into Q square over A square. And on this combination, if you will apply the Coulomb's law, 1 upon 4 pi epsilon naught Q into Q square over A square, means the magnitude of the force is same in both the cases. So let the force acting due to this charge at this point is a F, and force acting on minus Q charge due to this plus Q charge is also F. And all this is a equilateral triangle, so all these angles will be 60 degree. Now, in order to find out the net force at Fn, that is, you know, if the two vectors are P and Q, force is undoubtedly a vector quantity. If the two vectors are P and Q and they are entangled, they are making an angle theta with each other, then their resultant R is equal to under root P square plus Q square plus 2PQ cos theta. So same thing I am applying. Fn is equal to under root F square plus 2 F into cos theta is a cos 60. Now dear students, what is done? F square plus F square. Now cos 60 is what? Cos 60, you know, this 1 by 2 will be cancelled, so it is F square. Now it is F, this is, dear student, this is 3F square and that is F root 3. Or Fn, the net force at minus Q, that works out to be F is a 1 upon 4 pi epsilon naught Q square over A square, and that is root 3. This is the net force acting on charge minus Q. Now dear student, if this, we have to find out the force acting on plus Q charge, either this or on this. Now, this charge, I have told you that wherever you want to find out either the force, if you want to find out the electric field, you have to imagine a positive test charge at that point. But in the case of the force, charge is already placed. Now, this very charge will repel this charge like this, right? And this very charge will attract this charge like this. Dear students, sometimes what we do, we got confused that what the force will act on this due to this. If you are going to find out the force acting on this very charge, then you have to, what you have to consider that what force will act on this charge due to this, and what force will act on these charges due to this. There is no matter of it, right? You have not to consider that very point. Okay, what you are going to do, you are going to find out the force acting on this plus Q charge due to these two charges. So you have not to consider that what the force will act on these two charges due to this charge. Okay, so what we are going to do, we are going to find out the charge acting on plus Q due to these two charges. This very charge will attract like this, Again, the combination is same. The two charges are Q and Q in magnitude, and the distance between is a smallest. So again, I'm just supposing F. This charge will repel like this. This is F. Now, dear student, this time it is interesting. It is 60 degree. So the angle between these two forces is a 120 degree. This is 120 degree. Now, dear student, in this case, net force is equal to under root F square plus 2 F into F square cos 120. Dear student, if you know F square plus F square, very interesting result you will get. That is a 2F square, and value of cos 120 is actually minus 1 by 2, 2 will be cancelled. So it is a under root F square plus F square minus F square, this cancel, it is a F, and this is equal to 1 upon 4 pi epsilon naught Q square over A square. Now, the one very important fact that you should remember, you should always keep in mind, if the two forces, two vectors equal in magnitude and the angle between them is a 120 degree, then their resultant will be the same. Like the two forces F and F, the angle between them is a 120 degree, their resultant, their net value is also F. Is it? Now let's move further, dear students. Sometime this way, if there are the two forces, two vectors, and you know the angle between them, then it's easy to apply the this law, that is the R is equal to under root P square plus Q square plus 2PQ cos theta. But if at a point many forces are acting, then the only way is left, that is a resolution of vector component, right? That is resolution you have to apply, or you apply directly vector, like the force in terms of ijk, you find the force at a point in terms of ijk, and then add all these forces. Like at a problem is this time, let this is a minus q plus q plus q again, and this is an equilateral triangle. This time what I am supposing, a median. Median is a what? It is a centroid I am considering. Centroid is a what? That is a point of intersection of medians, right? These are the medians, right? Now, dear student, let at this center of the triangle, a charge is capital Q cap. Now you have to find out the field, the force acting on charge plus Q. What I have considered, the three charges are plus Q, minus Q, placed at the vertices of an equilateral triangle which is having the S, each S is small a, and at the centroid a charge plus Q, capital Q is kept. Now we have to find out the net force acting on charge plus Q. Now dear student, if it is a, then this distance is a by 2, right? This distance will be what? Let it is a y. Y is equal to under root a square minus a square by 4. Apply the Pythagoras, this square plus this square equals to this square. So y square equals to a square minus this square, that is a square by 4. That is a 4a square by 4a square minus a square means root 3a by 2, y equal to, right? Now dear student, this divides the centroid, divides the median into 1:2. This ratio, the base ratio is 1, and this from the vertex, this is 2. So 1/3 is this and 2/3 is this. So 2/3 of that much, that is consider 2/3. Let it is a y1, this distance I am considering y1, right? this very, y is what? This whole distance, and y1 I have considered this very distance of the centroid from the vertex. That is y1 is equal to 2 by 3 of total distance root 3 a by 2. 2 will be cancelled. That is a by root 3. This is a by root 3. A by root 3. This is also a by root 3. And this is also a by root 3. Everything is now clear. What I have considered, that three charges plus q and minus q placed at the vertices of an equilateral triangle which is having each edge is small a, and we have to find out a charge plus capital Q is placed at the vertices of the triangle, placed at the centroid of the triangle, where we have to find out the force acting due to all these charges. Now, dear students, I am making another very clear picture that will make you easy to understand. Now, look here, dear students, this is the equilateral triangle having each edge is small a. This is this is minus q, this is plus q, this is plus q, right? Dear student, this is the centroid where charge is q, and this is a by root 3. All these sides are a by root 3. Now at this point we have to find out first. This positive charge will repel like this charge like this. In all the cases, I am considering the force Fy because this charge and the distance, charge and distance is same, means whole combination is same in all the three cases. Here is charge is capital Q, small q, distance is a by root 3. Again in this combination, charge is capital Q, small q, minus or plus do not matter. So it will come into the direction, right? And distance again, and here the charge is capital Q, small q, and the distance between them is again a by root 3. Now, dear students, this charge will repel this like this. Let it is F. This charge will repel this like this. This is again F. And this way charge will attract this charge along the line joining them, and this is F. Right? The three forces I have considered because the charge combination and the distance between them is same. Now we have to find out the force on this charge capital Q. What we have done, this way charge will repel this along the line joining them. So the force acting on plus Q, capital Q charge due to this plus small q, that is F, due to this plus Q on this capital Q, this is F, and this way negative charge will attract this like this. Now dear students, what I am doing here, now look here, what I have to do. I have drawn a line parallel to x-axis passing through the centroid in order to find out these angles actually. Now dear student, this was 60, so it was 30, I am sure, right? If this angle is 30, then this is 30. Look here. What we say like this. If this is theta, then this is theta. Right? I think it's an adjacent angle or whatever said. I do not know. If this is theta, this is theta. So this one is at 30. Total angle was 60. It was the median. Will divide into two equal angles, right? So it is in case of equilateral, I am saying, right? Now it is 30, so this is 30, and this is 30, so this is 30. Now dear students, what we have got, it is a F having angle 30. Here is a F having angle 30, and here is a F. Now we have to find out the net of these values. This is F cos 30. This is F sin 30. This f has components f sine 30 and f cos 30. Now fx equal to 0. These two components will cancel each other. ds fy is equal to f plus f sine 30 plus f sine 30, that is 2f sine 30, and sine 30 is a 1 by 2. 2 will cancel, that is 2f. It is actually 2f sine 30, and that is a f plus 2f sine 30 is 1 by 2, that is cancelled 2f. Now f net force is what? Under root fx square plus fy square. Fx is 0, fy is a 2f, that is, so it is a 2f. R2, f is what? The force acting between these two, that is 1 upon 4 pi epsilon naught, capital Q small q, over square of this distance a by root 3 square. This is the net value of the force. Dear student, sometimes problem is asked like this. Problem might be like this. This is a plate, right? This is a plate. This is a positively charged plate, and this is negatively charged plate. The direction of electric field is from plus to minus, like this. A charge plus q enters in this way with velocity v, right? A charge plus q enters with velocity v within the plate result and hits at this, close to this point. Then question is that if the charge passes through, then how much time will it take to cross this plate, right? And what kind of path, what will be the trajectory of the path, what will be the shape of the path, what will be the motion of the path that charge flows through between the two plates. Now dear students, if you ever have history, I am very sure in the 11th standard you must have studied the projectile motion. What happens in projectile motion? This is projectile motion, right? One and only one acceleration is acting normally downward, right? In this whole motion, there is one and only one acceleration acting, right? Dear students, in this case, one and only one acceleration is acting. Now what happens? And this is ay is minus g. The vertical acceleration is minus g and horizontal acceleration is 0, right? In this case, only one acceleration is acting, and that is acting vertically downward. It might be horizontal acceleration might be acting and vertical acceleration is 0. Even then there will be path that will be projectile. Now in this case what happens? Look here. Body enters, electric field is this. Dear student, this is the electric field. As soon as the plus charge will enter, you know, due to electric field, positive charge experience if a q charge small q passes through the electric field capital E, then force acting on the charge q will be q into E in the direction of the force. If the charge minus q passes through the electric field, then the force acting on the charge will be QE but opposite to the field. In this case, the direction of the field is this, so the force will be act like this, Q into E. Dear student, you can say F is a, so acceleration on charge Q, that is A equal to F upon M. Let the mass of charge Q is small m. Dear student, F equal to ma, right? So A equals to F upon M. M is the acceleration of the charge Q when it enters between the two plates which has the electric field acting along the y-axis. Now you can write it AY, right? Now dear student, as soon as this charge will enter along the x-axis with velocity v, and this is acceleration is acting vertically downward. So the motion of the charge, the path of the trajectory will be parabolic. The same thing happens, dear student. This is a building, height h. A ball is projected with velocity u horizontally, then it will travel like this, right? Why will it come downward? Because of acceleration due to gravity that is acting vertically downward. That is why ball will come to the down, and it is why it is moving ahead horizontally, because you have thrown the ball horizontally with the velocity u. So because of this velocity u, it will travel horizontal, and because of this acceleration due to gravity, it will travel vertical. Now dear students, let this distance is small l. Now question is that how much time body will take to cross this, right? How much time body will take to cross this this L length plate, right? We have to find out that how much time the charge will take in order to cross this plate, right? Now let time is taken t. It is traveling with velocity v. So time I have considered, and this distance let the between the two plates is d. So time t is equal to distance upon velocity, that is L upon v, simply because it is if you apply, dear student, you can apply the same formula. You know S equal to ut plus half at square. For horizontal motion, S you can write, this is horizontal distance is L. It is ux into t plus half ax into t square. L ux is what is horizontal velocity, means the velocity with which a charge enters between the plate, that is q. That is v into t half ax. Horizontal acceleration, no horizontal acceleration. A vertical acceleration is acting, that is q upon m. So ax is 0. So t is equal to L upon v simply. Now dear students, we have to find out this. If this formula is applied for vertical motion, now it's interesting. Dear students, look here. S is a y, that is uy into t plus half ay into t square. Now y is that is d, distance between the two. Uy is 0. The charge enters with horizontal velocity, initial vertical velocity is 0. So it is 0 plus half ay. What is vertical acceleration? You just have find q upon it, even at the beginning of the question, into t square. So dear student, d equal to half q square e square or m square into t square. Now you can find the t like this. T is equal to 2m square or q square e square d and square root of that. It was actually t square 2m square d over that, and so t is equal to this. Dear student, I tried my best to let you understand the problems regarding to the electrostatics, but I'm a man, not machine. If regarding to my videos you have a problem in understanding the sentiments of the problem, then do comment, do recommend, do suggest. I will try my best to let you understand. Okay, least but not last, if you think that my videos are going to be helpful to you in your study, then do share, comment, like my videos and put the bell icon so that you can be notified about my next video. Till then, meet you. Bye bye.